Question 3 on your kinematics. So a car moves from traffic lights along a straight line with constant acceleration. The car starts from rest at the traffic lights, and 30 seconds later, the car passes a speed trap where it is registered at 45 km per hour. Find the acceleration of the car and the distance between the traffic lights and the speed trap. So let's get a little picture drawn of this. So here's our road. So it's going from traffic lights and then a speed trap. So traffic lights, this one doesn't have amber, and then speed trap. Don't know what it looks like, but we'll make a little camera. Okay, so it's starting at the traffic lights, starting from rest. So if it's going from the traffic lights to the speed trap, this is our positive direction, this is the direction of travel. And it's starting at rest, so u will be 0 meters per second. Constant acceleration. It's accelerating this way. 30 seconds later it passes the speed trap, so it's 30 seconds from here to here. And its speed at the speed trap is 45 km per hour. Okay, I don't like the look of the kilometers per hour because normally we deal in meters and seconds, so we're probably best off converting to meters per second before we go anywhere with this. Okay, the acceleration is constant. We don't know what it is. That's what we're trying to find in part A. But let's convert our 45 kilometers an hour to meters per second. So 45 kilometers an hour is the same as 45,000 meters per hour. 1,000 meters in a kilometer, so just times by 1,000. If you're going to go from 45 kilometers, that's the same as 45,000 meters. And to get our time matching up, to get it in meters per minute, which should look a little bit like this. It's a little bit ugly because meters and minutes are the same thing. We divide by 60, which is 750. I'll just write it as per min, for it looks a bit nicer. And then per second is going to be that divided by 60. To give us meters per second, which is 12.5 meters per second. So I'm just going to replace this up here with 12.5 meters per second. Really important, the time certainly is in seconds, because this is in seconds and it'll time with this. And we normally talk about meters when we're doing these kind of questions. So it's good to have that converted as well. But there's our conversion, so now we can have a look at part A. So part A is find the acceleration. So to find the acceleration, we've got u at 0. We've now got v, which is 12.5. We haven't got a. We have got the time it takes, which is 30 seconds. So here we can use v equals u plus at. Good idea to have all the equations next to you when you're doing this, so you can pick out which one you need, especially when you're first doing it. So v is 12.5, u is 0, a we don't know, and t is 30. So we'll just get 30a equals 12.5, divide by 30 on both sides. So our acceleration should be 5 over 12 meters per second. Which is a bit ugly as a decimal, so we'll just leave it as a fraction. Okay, but our time is in seconds. Obviously our speeds are in meters per second now. So there's our acceleration, so that's part A. And part B says the distance between the traffic lights and the speed trap. So we're trying to find this distance here. So it's the displacement from the initial position at the traffic lights to the position at the speed trap. Okay, so this we can call this S, and we can solve from there. So again, we've got U, 0, we've got V, 12.5, we've got T, which is 30. You could use A if you wanted to, and we're looking for S. But we've got a formula linking these, which is S equals a half U plus V T. Sub in, S is what we're trying to find, a half, U is 0, V is 12.5, T is 30. So this is a half 12.5 times by 30. If we stick that into our calculator, we get 187.5 meters. So the distance between the traffic lights and the speed trap is 187.5. That's question 3. And question 4. So only one part to this. A particle is moving along a straight line from A to B. So we need a diagram again. With constant acceleration 5 meters per second squared. The velocity of the particle at A is 3 meters per second in the direction A to B. The velocity of the particle at B is 18 meters per second in the same direction. Find the distance from A to B. So here's our particle at A. Here's our particle at B. We're going from A to B, so our positive direction, will be left to right again. The direction from A to B. Constant acceleration 5 meters per second squared. So acceleration is positive, we're going this way. 5 meters per second to the minus 2. The velocity of the particle at A is 3 meters per second, so our initial velocity is 3 meters per second. And the velocity of B is 18, so in the same direction, V is 18 meters per second. And we're asked to find the distance from A to B. So that will be the displacement from the initial velocity to the final velocity. This will be S here. Get rid of the ruler. So we have U, which is 3, V, which is 18, our constant acceleration of 5 meters per second squared, and we're looking for S. So our formula which links these variables is V squared equals U squared plus 2AS. V is 18, U is 3, A is 5, and we don't know S. Just tidy this up, 18 squared is 324, and 3 squared is 9. 2 5s are 10, so this is 10S. Rearrange, so subtract 9 from both sides. Divide by 10. So S will be 31.5, and it'll be in meters, it's all in meters and seconds. That's question 4.